All right, let's get our last page of notes for our quadratics and completing the square, example 4. So what if you have something that looks like this? If you notice, I now have the x is actually on the right. And so the first thing that we want to do is rewrite it in standard form, just to kind of get an idea what is going on here. Excuse me. So we're going to use the addition property of equality, and we get it in our standard form. But we notice that 79 is not a perfect square. So right now we're going to be looking at complete the square. So step 1 is to move it over. So you are welcome whenever you get things that are not set up in standard form to rewrite them in standard form first, and that helps you solve things and to start the initial process. Once we have done that, here is another little bit of information. We need to have, or at least if we can, to have a equals 1. And you do that by simplifying, or basically dividing everything, and I mean everything, both sides of the equations, by a. And this will simplify this down to 1. So you might be left with a fraction, and that's okay. Just work with the fraction regardless. So we have it that we're dividing by 9, dividing by 9, dividing by 9, and keep all fractions. Once we've done that, we can then find our b. So b equals 2. So we're going to plug that into our formula, the complete the square formula, and find out what our c should be. Once we have done that, we're going to use the addition property of equality and add it back into the equation, keeping it balanced on both sides. But if you notice over here, we have a denominator of 9. And we don't want to have this be a mix and improper. It's already kind of, right now it's already an improper, so we don't want to mix improper. So what we're going to be doing is actually turn that 1 into a unit fraction. So using this denominator down here, use it to create an equivalent fraction, and if this happened to have been a fraction, then we just do the same thing, turn it into an equivalent fraction with a common denominator. And so now we can simplify these two sides over here. So you'll notice all these steps are the same basic steps. Once we have simplified, we can rewrite it as factors. Okay. Now this is the only time, well, and you should have your b, and remember, your b divided by 2 will give you this quantity here, and that still stays true in our factors. So then we're going to write it as a square. And so now we can start solving for x. So let's go ahead and move this up. So we are going to square root both sides. And when you have a fraction like this that is being square rooted, you can simplify that into a square root in the numerator, extend that out a little bit more, and a square root in the denominator. Not only that, but this happens to be negative, which means I can then break this into the factors of 70 times negative 1. And you can ask yourself, well, is 70, can I simplify that any further? Well, can 4 go into it? Can 9 evenly? Can 16, 25, 36? And so, no. we can't simplify that to 70 any further besides taking out the -1. So if I break those into two separate radicals, the square root of -1 is I, and then the 70 remains the same. But the square root of 9 is 3. So, and then we have our plus or minus here. We're going to create our two equations next. One with an addition, and start solving it. And so when we do that, we're going to subtract 1 from both sides. But again, what we can do is we can rewrite this using the denominator here to create our equivalent fraction of 3/3. So initially what ends up happening, there we go, is that you get -3/3, which is the same thing as -1. But then when you add it to this over here, since they have the common denominator, you can just rewrite it all over the like denominator. And so that's a little trick of oftentimes you'll see them written with the answer like that, and that is how they get it. So your second equation, I'm just kind of getting down here towards the bottom, is with a -I. So again, we're going to do the exact same steps. We're going to be, instead of subtracting 1, I just subtracted 3/3, brought it here. It combines same exact way, since it's a common denominator and like denominator, that I can just put it all over the 3, and then I can do step number 12 and write my two solutions. So that is one of the other ways that you'll see things, and I want to make sure that you had an example to put it in your notes. Please make sure that you pause as often as you need to, and I hope this helped.